All right, hello there. And here we go with section 10.2. Section 10.2 is all about arithmetic, sequences, whoops, and series. All right, so remember a sequence is just a list of numbers. Like I said in the last video, it follows a certain pattern. And a series is when you take that list of numbers and add them up. Arithmetic is when you have an adding pattern, or it could be a subtracting pattern. But remember, a subtracting pattern is like adding a negative. So if your common difference is negative, then that's why it looks like a subtraction. And if your common difference is positive, then it's going to look like addition. All right. So here we go. So let's start with this first example. Let's say we have this sequence right here. So 50, 46, 42, 38, and so on. So there's going to be some things we have right here. What we're going to try to do is find a formula for what's going on. So there's going to be some terms. There's going to be A1. A1 means first term, so it would be 50 in this case. There's going to be D. D is the common difference. So A1 first term. D is a common difference. And the way that you find the common difference is you take a term and you subtract the one before it. So like in this case, I'm going to take, how about if I take, I don't know, 38 minus 42. So 38 minus 42 is negative 4. So I can tell that this thing is going down 4 anyway, but my common difference is negative 4. All right, and so then we're going to try to find a formula. So a formula for the nth term and nth term just means like the generic term that you're looking for is this. It's an equals a1 plus parentheses n minus 1 times d. So let's go ahead and do that here. So my nth term now in math space they use tn instead of an. My nth term is going to be a1, so a1 is 50 plus n minus 1. I'm going to leave that alone because n is like the number of term, like the number that I'm on, the spot number, so that's going to be part of a formula, and then d is negative 4, so I'm going to put parentheses around that negative 4. All right, so I'm just going to multiply this out and get to work here. So I have an, I got 50, b minus 4n plus 4, so if I clean that up, I have negative 4n plus 54. And so what should happen here, if I go and try some things, like let's say I try a1, well if I plug 1 in there, I get negative 4 times 1 plus 54. And look at that, I get 50. What if I plug in like 3? So negative 4 times 3 plus 54. So that would be negative 12 plus 54, so that would be 42. And so look at that, I get the third term, and back before I got the first term. All right, and so this gives you a way of finding a formula for the pattern that's going, that arithmetic pattern that you go right here. So this is all for arithmetic nth term. There'll be some other formulas coming in that I'll tell you about too. All right, so another example, another thing you're going to have to know how to do is how to insert arithmetic means, they're called. So let's say we have this list of numbers, 16, and then you have 1, 2, 3, 4, 5, 6, 7 blanks. So 7 blanks. And then you finally have the number 20. And I want to insert, this is supposed to be an arithmetic sequence. All right, so you kind of have to be told that up front because who the heck knows what's going on if you're just given 2 numbers and a bunch of empty spaces. And so there's a couple ways to do this. I want to insert all the evenly spaced numbers right here. Remember, this is also called inserting arithmetic means. All right, and so I have to look at this. My first term is 16, and so you can look at it a couple ways. You can say to yourself, let me see, I have to go from 16 to 20. So that's covering 4 units. I'm going up 4 units. And then I say to myself that I'm doing that in 1, 2, 3, 4, 5, 6, 7, 8 jumps. So if I'm going 4 spaces and 8 jumps, I take that 4 spaces divided by 8, means I have to go 1/2 each jump. All right. And so that's one way to think of it, like real simple. There's another way to do it is to say to yourself, well, I have this 20 term right here, and I know my first term is 16. Let's figure out what the common difference is. So if you look at this formula here, the nth term is 20, all right? The first term is 16, and the n minus 1, the d I don't know, but the n minus 1, I can say to myself, well, if this is the first term, this is 2, 3, 4, 5, 6, 7, 8, 9. This is the ninth term, so 9 minus 1. So I can figure out what d is from here. So it'd be 20 equals 16 plus 8d. So if you solve that, you get d equals 1/2. So you could do it that way. So either way, you can know that you're going up by a half. So of course you get 16.5 right here, then 17, then 17.5, then 18, 18.5, 19, 19.5, and 20. And then that should all just kind of, work out really nice and smoothly. All right. All right, so the next thing we're on to our series, arithmetic series. So remember, an arithmetic series is when you take the terms from a sequence and you add them up. So I'm going to ask you this question. What is the sum of all the odd numbers starting with 1 to 99? Okay? And so that would be like adding up 1, 3, 5, 7, 9, and so on, all the way up to 99. Okay? So you have a couple ways to think of it. First of all, both ways are going to involve you knowing how many terms there are. Okay? So I'm going to have to figure out how many terms there are, or I can also basically figure out a pattern for this right here. But first I need to figure out how many terms there are. So like we did before, I'm going to use this formula. I got a1 plus n minus 1 times d, my nth term formula. My 99th term, or I'm sorry, I have a term of 99. a1 is 1 plus, this time I don't know n minus 1, but I do know the common difference is 2. So if I solve that, I get 98 equals 2 times n minus 1 divided by 2. I get 49 equals n minus 1. So n equals 50. So that means starting at 1 going to 99, there are 50 terms in that pattern. So if you wanted to do this on your calculator, you could do this. You could do n equals 1 to 50, come up with a formula to put in here, and my formula would involve this right here. My nth term formula is a1, which is 1 plus, leave n alone. My common difference is 2. So if I clean that up, I would get 2n minus 2 plus 1, so minus 1. So you could put that right in here, stick that right in your calculator. So that'd be a lot of numbers to add up yourself, so we don't really want to do that. So there is an alternate way to do it, another formula, and this is for the sum of an arithmetic sequence, right? So that formula goes like this. Sn equals, so the sum of n things, n over 2, a1 plus an. Now, a1, remember, that's the first term. an, that's your nth term. Or in this case, your last term. So I'm going to be summing up 50 things. So I have 50 over 2. a1, the first term, is 1, plus the 50th thing is 99. So I'm going to go ahead and get my answer. 50 over 2 is 25, and 99 plus 1 is 100. So I get 2,500, which is the same thing you should get on your calculator if you entered this guy right here. All right. Now, there is one other way to do a formula like that, and I'll show you on the next page. So same setup, same problem we're doing. So we got 1, 3, 5, on and on to 99. All right. So one other way to do this is to use the fact that, oh, never mind. That was it. Sorry about that. I was thinking about something else. So let me erase that there. All right, that was coming up later on. All right, so let me show you how to do this. The sum of a series here, an arithmetic series, if it comes up in a sigma notation. So yeah, n equals 1 to 10. Now you have to learn to recognize or at least write it out, an arithmetic sequence. So an arithmetic sequence is going to kind of look like y equals mx plus b. It's going to look like the equation of a line in a way, except your variable is n. But any arithmetic sequence, it could look like this. Arithmetic sequence could be like, 5n, or it could be like negative 2n plus 1, or it could be just, 6n or negative 6n. So it's going to look like you would think an equation of a line could look at. It might have a starting place, and then it has like a slope to it almost. All right, so that's how they look. But if I do this, I can use my formula. I'm going from 1 to 10, that's 10 things. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's 10 things. So I'm doing the sum of 10 things. So I put 10 over 2. I want my first term. Well, my first term is when I plug 1 into this formula. All right, so negative 3 times 1 plus 5, so it would be 2. Plus, now I need an. So the 10th term, the last term in this little series that's written out here. So if I plug in 10, I get negative 3 times 10 plus 5. So negative 30 plus 5 would be negative 25. Right, and so there we go. And or, of course, by now you could have also put this in your calculator, but say you weren't allowed to use your calculator. All right, so let's see, I get 5, and this is negative 23. So I get negative 115. All right, so the last example we have here, oopsie. Well, I guess I don't have another page. There you go. All right, my last example is this. Let's say we want to find the sum of the first 50 terms of this sequence. All right, so the sequence goes like this: 12, 12.25, 12.5, then 12.75, then 13, and so on. So you can see that I'm adding 0.25, right? So you can tell me that my common difference is 0.25, my first term is 12, and the crappy part about this, though, is if I want to use my formula, that good old sum formula, I have n over 2, a1 plus an. I'm like, okay, n, I got that, 50 things. A1, I got that, so I could, plug in 12 for that. And the only thing I don't have an, I don't have the 50th number. So if you wanted to, you could find the 50th term. The 50th term is a1, so a1 plus n minus 1 times d. I would do a1, which is 12, plus 50 minus 1 is 49, times d, which is 0.25 here. You could do it that way. Or you could change your formula to this. Sn equals n over 2, a1 plus, an is this formula that I put right here. So we could kind of plug that in, and this is an alternate formula for a summation, and we would get right here, I would get a1 plus n minus 1 times d. And so this creates a new formula for us that maybe some of you use, 2a1 plus n minus 1 times d. Okay, so I'll just use that. So I have 50 over 2, 2 times the first term, so 2 times 12, plus n minus 1. Remember, I'm having the sum of 50 things. So that'd be 50 minus 1, which is 49, and d is 0.25. Ugh. All right, so I get, let's see, 25, and then inside I have 24 plus 49 times 0.25. So when all is said and done, this adds up to, or goes out to 906.25. So that'd be the sum of everything in this list, the first 50 things in that list right there. So anyway, let's just summarize the formulas that you have right here that we've done. All right, so for an arithmetic, all right, you have the nth term formula is an equals a1 plus n minus 1 times d. Then you have the sum formula, the sum of n terms. You have two formulas. You have Sn equals n over 2, a1 plus an. And you also have Sn equals n over 2, 2a1 plus and minus 1 times t. So you could use any of those things there. All right, and that is it.